Hi everyone, how are you all doing? Teacher, hope you guys are doing great, amazing. So today in this video, we are going to continue with chapter 2, differentiation revision questions, just to help you guys prepare for your current mid-year exam. Alright, so let's get started. So in this chapter, we will start by, before we start, okay, make sure you have downloaded the question module. Okay, the question module is in the below description box. Okay, I have attached the Malay and the English one together as well. Okay, so it's easy for you to choose which one you want to download. All right. Okay, let's get started. Okay, usually for limit, okay, for limit kind of functions, we use direct substitution. Okay, so let's, for this example here, question 1 is direct substitution. So for A, okay, limit of x approaching 1. Okay, so we substitute limit of x approaching 1. So the moment you substitute the 1 inside the function, you don't have to write the limit already. So your answer here will be 6. So this is a 1 mark question. Okay, so 1 mark question is quite straightforward. B, substitute, okay, direct substitution of n. N is approaching 1. Okay, so substitute as 1 plus 1 over 1. So it's 2. So whenever you get answer as whole numbers, so that means direct substitution works. Okay, it's okay for your what is this differentiation here, the limit here, sorry, the limit. Okay, let's substitute here x approaching 0 into the k. Is this sorry, into the x? Okay, so remember, you have to substitute into the x, not the k. So 3k over k, 0 plus 2k. So as you can see here, already becomes 0. So you're left with 3k over 2k. Anything that you can simplify here, simplify. K can cut. So our final answer is 3 over 2. Okay, so this one is quite straightforward. We already found. Okay, so for number 2, also the same. All these direct substitution. Okay, because if you can do direct substitution and you get value means, all right, then it's already okay. You don't have to do any changes or anything. So here will be square root of 10 plus 6. Right, 16. So square root of 16 is 4. All right, next one, limit n approaching 4. 5 minus square root of 4. Oops, so wait, when you're already substituting the value, okay, you don't have to write the limit. Okay, actually here don't have to write the limit if you're already substituting. Okay, so here also again, teacher just straight away substitute. So 5 minus square root of 4 over 4 plus 2. That means 5 minus 2 over 6. 3 over 6 is equals to 1 over 2. Okay, and the last one, substitute 0. So straight away teacher substituting 0. Square root of 0 is 0. So negative 4 over negative 2, we get positive 2. Okay, so this one all is quite straightforward. Now let's move on to something that, yes, you need factorizing or you need to rationalize the numerator or the denominator. Okay, let's look at this one. Okay, if I substitute 2 inside, so you see 2, if teacher substitute 2 inside, you see below you get 0. Up also you get 0. 0 over 0, what it means? Nothing, right? So you cannot get your answer 0 over 0. Therefore, you need to do some changes. You need to change either the numerator or the denominator. But in this case, it looks like we can do something with the numerator. Okay, why? Because the numerator has a higher power, right? Okay, remember, when you have something like in this case, a square minus b square. Okay, please remember this shortcut. It will be very helpful for you. you can write as a minus b and a plus b. Okay, this is very important. Remember the shortcut. Okay, so now in this case, this is actually 2 square. 2 square is 4, right? Minus n square. So how do I write this? 2 minus n, 2 plus n. So now I'm going to rewrite again. Limit of n approaching 2, 2 minus n, 2 plus n, divided by 2 minus n. Can you see similarity between the up numerator and the denominator? Can, right? So we cut which one is similar. Okay, so since cut ready, what are we left with? Limit of n approaching 2 for 2 plus n. So now you substitute 2 plus 2 is 4. So the answer, the limit value here is 4. All right, how about b? What can we do for b? If you see up, all right, it's you have n square minus 3n. So you can see that here also got n, here also got n. There's 2n there. So you factorize the n out. So it's going to be limit of n approaching 3. Take out the n. Okay, take out the n. So you are left with n minus 3. Below, anything can factorize out or not? Yes, because you see the number there, 2, right? 2 is a common factor for 2 and 6. So we are going to take out the 2. 2 and minus 3 also. So this kind of the factorizing skills all by now, please update yourself, okay? Do a lot of practice for this kind of factorizing skills. So you see n minus 3 and n minus 3 can cut. So we are left with limit of n approaching 3 for n over 2 only. So the n over 2 straight away can substitute. I get 3 over 2. So done, ready. Okay, so we are done. Okay, let's look at question 4. Okay, question 4 looks more like complicated, right? Okay, especially if you see like a power and all, try to simplify and make it as small as possible. Okay, as small as possible. All right, so now let's look at the first one. Okay, limit of n approaching 1 over 2. Okay, 2n square plus 5n minus 3 over 2n. So the up one here is quadratic. Okay, how do we simplify the quadratic? What do we do? How do we simplify the quadratic? So we can use our calculator to simplify the quadratic, isn't it? Okay, so you substitute everything inside your formula. Okay, equation degree 2. The first value of A is 2, value of B is 5, the value of C is negative 3. So 0.5 means 1 over 2. Okay, that means the first n, I'm going to write it this way. 1 over 2 means 2n minus 1. Okay, and the other one is n plus 3. Because this is the value that you get, right? 1 over 2 or negative 3. So you just have to move it in front, times and move it in front. So make sure these skills all, you are already, it's in your fingers. Okay, so now let's write this. So 2n minus 1, n plus 3. Okay, divide by the denominator is 2n minus 1. Okay, so cut. Which one can cut? Cut. Okay, now we are left only with limit. You see, whenever you haven't substitute the limit, keep writing down limit. Okay, now only I'm going to substitute in. So 1 over 2 plus 3. So we get 3 1 over 2. So our answer done for A. Alright, now you guys try for B. Okay, look, up and down both also have quadratic equation. So factorize the up one, factorize the down one. Okay, try here, you're working, pause. Your final answer, you should get 2 over 7. Okay, pause this right now. Try. If you get the answer, comment below 2 over 7. So teacher will know you have tried and you have got the answer. If you didn't get, no worries, comment also and tell teacher how you did exactly. Okay, I can guide you from that. All right, now let's go to, okay, this question is almost similar. Find the values, you substitute and find. Okay, if let's say you have a cert, okay, you have cert, what must you do? Especially, okay, you see, for example, the first one, question 6, you substitute the 0 in. I'm just going to straight away substitute 0 plus 1 minus 1 over 0. So I will get 0 over 0. Can I have my answer as 0 over 0? Cannot. Therefore, I must do some changes. Since there is a cert here, what is the changes that we must do? We must multiply with the conjugate. Okay, look at the cert here. The cert is cert n plus 1, then minus 1, right? So the conjugate will be cert n plus 1 plus 1. Okay, it's a little bit different compared to the first, the form 4 one that you learn. Okay, here cert n plus 1. Okay, then the minus 1 you change to plus 1, and then we might and then we times now. Okay, so limit n approaching 0, okay, for okay, cert n plus 1 minus 1 over n, up and down we multiply with the conjugate, n plus 1 plus 1 cert n plus 1 plus 1. Okay, so now let's times. Okay, the up one, what will happen when you multiply? Okay, be careful when you multiply, put a bracket if you can't see. Okay, the first times with the first, second with the second. Okay, usually there's a shortcut for this. Okay, now the shortcut is very easy. If let's say it's a plus b and then a minus b. Okay, if you get in this form, the answer will always be a square minus b square. Okay, this is a shortcut. So here this is our A and B. Here this is our A and B. Okay, if teacher don't want to do one by one, this is what I will suggest everyone to learn. Okay, the more shortcuts you learn, the more time you save in exam. So A times A, square root times square root will be gone. Okay, n plus 1, square root n plus 1. What will happen to the square root? Square root will go off already. So you're only left with n plus 1. Okay, just take n plus 1 only. Okay, then what is this? Minus b square. Okay, so let me write it back nicely for you. Okay, let's say I'm following this form. So I'm going to write my A. A is square root n plus 1. Then put square minus b. What is the value of b? B is 1 square. Put it this way so it's easier. Okay, so square root and square can cut. Square root and square can cut. So we are left with n plus 1 only, minus 1 over n. So 1 minus 1 is 0. Is it? Oh, sorry. This one I forgot to times. This one also must times, the below one. This times this and this times this. So the below one is n square root n plus 1 plus n. Okay, now we can substitute in. Okay, n square root n plus 1 plus n. Okay, so the up one, 1 minus 1 gone already. So the final part, we are left with n over n square root n plus 1 plus n. Okay, can you see some similarities between the numerator and the denominator? The denominator, actually, we can factorize the n. Okay, so actually in the beginning, we don't even have to times in. So the n is just like this. We could have done like this. Okay, so now the n and n can cut ready. So the final part we are left with, hold on, let me just add one more page here. Okay, so limit n approaching 0, 1 over square root n plus 1 plus 1. Okay, so from here it's going to be 1 over square root 0 plus 1 plus 1. So that means it's going to be 1 over 2. Alright, so this is the answer for A. So similarly, try for B. Okay, pause this. Try for B and you should get the answer 1 over 4. Alright, so if you get the answer, do comment that you got 1 over 4. Just comment 1 over 4, teacher will know. Okay, alright. Okay, so far so good. Okay, this is all also similar. Okay, if you see, you directly substitute, you get 0 over 0, then you must do some changes. Okay, you can also pause this, try question 7 by yourself. Okay, if you have downloaded this, very good. Okay, download this means you straight away can do all these questions. All right, now if let's say you have to substitute infinity limit, okay, you have to substitute infinity. If anything, power of infinity will always be automatically 0. Okay, remember, if your power you have to put as infinity, means 0.5 infinity, you straight away will get as equals to 0. Okay, that one remember. Same similar to here also. 2 over 5 power of infinity, straight away get 0. Okay, now let's look at next question. Okay, if you cannot get your limit, let's say you cannot, you substitute, you cannot get your limit, right? For example here, 3 over 6 plus infinity. What is 6 plus infinity? 6 plus infinity will be infinity, isn't it? Because big number one. So if 3 divide by infinity, what will it become? Okay, this is a rule that you must remember. Okay, if let's say your infinity is below, okay, is below means your final answer will equals to 0. Okay, if you have infinity below, for example, like this one, okay, let me show you nicely. Okay, so 3 over infinity, what teacher is going to do? 3 over 6 plus infinity, right? So it's going to be 3 over infinity. If you have infinity below, your answer will become 0. Because 3 divide big number. For example, 3 divide 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. Got 13 zeros, for example. You can key in calculator. You will get 0 point something. Okay, you will get a very big long 0.000 something. All right, so that's why it's equals to 0. Similar here. All right, let's see, now I'm going to substitute the infinity here. Okay, see, 3 infinity over 5 minus infinity. Up also infinity, down also infinity. Cannot. You have to do some what is that, simplification. Okay, so up cannot be infinity. So what you do, we are going to uh, remove the n on the numerator. Okay, by we are going to divide with n, divide both the numerator and the denominator with n, because up we don't want n. If we got n on top, it's going to be difficult because you're going to get infinity over infinity. So what's going to happen is it's going to be like this: 3n over n, 5 over n minus n over n. So we will get limit n approaching infinity 3 over 5 over n minus 1. Okay, because here n and n can't really. So now you substitute the infinity. So 5 over infinity. What is any number divide with infinity? Any number divide with infinity will become 0. So 0 minus 1 is -1. So this becomes -3. If you feel teacher too fast, okay, you can press a slow speed. Okay, you reduce the speed of this and then you watch again this part. All right, so I hope you get the answer. Okay, you understand? Okay, now similar to B 10 also, question 10 also. If you see up there the power, okay, and then you want plus infinity. Okay, for example, number question 10. Okay, question 10, here is this. See, for example, here 1 plus infinity square over 3 plus 2 infinity square. So infinity and infinity square cannot solve. You cannot get like that. That's not the rule. So what you need to do is eliminate the n square which is on top there. So limit of n approaching infinity, you divide up and down, okay, by n square. Divide both up and down. So it will be 1 over n square plus n square over n square, divide 3 over n square plus 2n square over n square. You see, the moment you do this, okay, here which one can cut? We cut. Then when you write again, limit, okay, approaching infinity, 1 over n square over 3 over n squared. So now when you substitute the infinity, okay, what it becomes? 3 over infinity. So it becomes 1 over 0 divided by 3 over 0, isn't it? So 1 over 0 over 3 over 0. Hold on, am I writing this? Oh, sorry, there's plus 2 here. Plus 2, plus 2, plus 2. Okay, that is what. You forgot to write this. Okay, plus 2. So what's going to happen here? 1 over infinity is 0. Wait, am I doing this correctly? I think I also left out something here. Hold on. Let me recheck back. I think something went wrong here. Okay, 2, yes. So when I write back, limit n approaching infinity, 1 over n square. N square over n square, cut really becomes 1. Forgot to write the 1. Because you cut, here you cannot just cut. Because got plus in the middle there. Okay, because of this plus, I need to write the 1. Over 3 over n square plus 2. Okay, now it makes more sense. Okay, now you can substitute the infinity. Yeah? So 1 over infinity square plus 1 over 3 over infinity square plus 1. So 1 over infinity is 0. 0 plus 1 over 0 plus 1. Again. I'm so sorry. Okay, plus 2. Plus 2. Alright. Yeah. Okay. Plus 2. Alright. Because teacher just completed an entire day of classes. So a little bit tired. Okay. So 1 over 2. Yes. Now correct answer. 1 over 2. Alright. So now let's see if you can try B. So here, which is the biggest power here? N power of 3, right? Okay, so you divide everything by n power of 3. Always divide with the biggest power. So you will get the answer 2 over 5. Okay. Alright, so now let's try some questions where you can see first principle, also very important. Please make sure you know the steps. Okay, please make sure you know the steps. I have shown this in my for differentiation, how to do the steps one by one. Okay, so I'm just going to show one example here. Okay, let's start with our first principle. This is also quite important. Okay, teacher is going to show the first example. Okay, because I have this example a lot in my video. So please have a look. Okay, just make sure that you know at least how the steps. Okay, there's actually 3 steps only. Okay, first step is find the delta y. Second step is find the ratio. And the third step is find the limit. That's all. You will already get your first principle. Okay, let's start off. Okay, let's start off. This is given as y, right? So teacher is going to change my y as fx. So I'm going to write fx equals to 1 over 4 x squared. Then put into the formula delta y. Delta y is fx plus delta x minus fx. This one, please refer to your textbook. It's already in the textbook there. Okay. So now what I'm going to do is, okay, I'm going to substitute this one. All right. Can you see this? I'm going to substitute this inside the x. So that's what we are doing. We're going to substitute the x plus delta x inside the x. So it's going to be 1 over 4 x plus delta x squared minus fx. What is fx? 1 over 4 x squared. Okay, so now what we're going to do is, so minus all this. Okay, now we do expanding. Okay, so we expand, we get 1 over 4 x, Before you expand the 1 over 4, expand the bracket first. This is very important. Expand this first. Huh? Okay. So it's going to be 1 over 4 x squared. Teacher is going to use the shortcut. So I've do shortcuts a lot of times. Please make sure you know how to do the shortcut. Okay, if you've watched teacher's other video, I've done a lot of examples like that. Okay, even form 4, chapter 2 also got. Alright, so now we expand in. So 1 over 4, okay, 1 over 4 x square plus 1 over 2 x delta x plus 1 over 4 delta x square minus 1 over 4 x squared. Okay, so when we minus all this right now, what's going to happen? This cancel off already. We are only left with that one. Okay, so delta, hold on, delta y is equals to 1 over 2x delta x plus 1 over 4 delta x squared. Okay, up to here, first step is done. This one done, first step. Now let's do the second step, find the ratio. So what you're going to do is you're going to divide both sides. This is the step 2. Divide both sides. Divide both sides with delta x. Okay, so that means delta y goes to 1 over 2 x delta x plus 1 over 4 delta x squared. So divide delta x, divide delta x, divide delta x. Here can cut, here left power of 1. So now we can write as delta y equals to 1 over 2x plus 1 over 4 delta x. Step 2 done. Now let's focus on the last step, finding the limit. Okay, finding the limit of dy dx. Okay, so the final one we write like this, limit. Okay, so this is now we are finding dy dx ready. Dy dx, limit of delta x approaching 0. For this, okay, for this teacher didn't write here. Okay, it's fine. For this is going to be copy the entire 1 over 2 x plus 1 over 4 delta x. Okay, copy the whole thing. Now substitute the 0 where? Where do you substitute? Because this is for delta x, substitute for here this part. So 1 over 2x plus 1 over 4, 0. So here becomes 0 already. So our dy dx is 1 over 2x. Okay, so we already got the final answer. So there's only 3 steps and we have 3 marks. Okay, so the final answer is this. So please repeat this. Okay, try to see again how teacher do. And if you still don't understand, do watch teacher's differentiation video for using first principle. Okay, I've done very in detail, very much in detail. So try question 15. Try question 15. Write your answer in the comment section below. Okay. All right. Let's move on. Let's move to move away from first principle. We go to first derivative. Okay. You guys still can remember how to find first derivative. All right. Let's look at maybe this question. The simple ones first. Okay. Finding first derivative is like you've using the x, you don't have to use any rule yet, like chain rule or nothing like that. Okay, so make sure first derivative all you guys score in exam. Okay, like the first one here, y is equals to 2 over 3 x power of 6 minus x power of 4 over 2 plus 1 over 5. Okay, when you find derivative, what you must do to the x? Okay, the x, first of all, your power you must bring down and times in front. Okay, so 6 times 2 over 3 will become 4. X, what will happen to the power? The power will minus 1, isn't it? So 6 minus 1 is 5. Okay, minus here, what will happen to the 4? The 4 will come in front. So 4 divide 2 will be 2x. and then the power will become minus 1, right? So 3. And here 1 over 5 got any x? Nothing. So this one 0, no need to differentiate. So that's all. Okay, this one is quite easy. Okay, teacher's going to skip this one. Okay, this one also. So if you have your, let's say your x is down, like question 20, what you must do is bring your x come up first. So 2x plus 2, x negative 1. Bring the x come up. Then you differentiate. So dy dx will be, here power of 1, isn't it? So 1 times 2 is 2. Then what will happen to the x? 1 minus 1, 0 already. So x no need to write. Okay? If the power 0 already, don't have to write. Then this one, negative 2 times, negative 1 times with 2, negative 2x. And then here, negative 1 minus 1 is negative 2. So rewrite back these nicely. Don't leave the power as negative. So 2 minus, we write down this side. Okay. Right here, dy dx is 2 minus 2 over x square. Bring the x down back because the x power cannot be negative. Usually the final answer, we don't leave it as negative. Okay, so you guys can try question 20b. Okay, and if you have square root, okay, what you do is change first, the form, change first. So 3 over 2 x power of 1 over 2. Square root, change the power. Power 1 over 2 plus 2 over, here will be x, what power? 1 over 3. Okay, power 1 over 3. So don't leave, if the x is down, don't leave it down. Bring it up first. Plus 2 x negative 1 over 3. Bring it up first. Then only you find the differentiation. So the first derivative will be, we change color. Okay, 1 over 2 times 3 over 2 is 3 over 4 x. 1 over 2 must reduce by 1, isn't it? So minus 1 becomes negative 1 over 2. Okay, then negative 1 over 3 times 2 is negative 3 over 2. Then here x will become negative 1 over 3 minus 1, negative 4 over 3. Okay, if the powers are negative, don't leave it like that. Bring it down. So becomes 3 over 4 x 1 over 2 minus 3 over 2 x 4 over 3. But usually you don't write like this also. Okay, we change the form a little bit more. 3 over 4 square root x. Okay, 1 over 2 means square root. Then here 3 over 2. Power of 4, where do you write? Power of 3, where do you write? So the down one you write outside. The power of 4 you write beside the x, like that. Okay, so we leave it up to here. Okay, done, ready. Okay, so next one, let's look at, okay, if you have equation and equation beside each other, okay, what you should do? If you can see here, you got bracket with equation, bracket and equation. Okay, usually there's two ways. Here, since the bracket don't have power, okay, the bracket doesn't have any power, right? So you can expand the bracket. Okay, we expand the bracket. So let's say this is y. Usually if there's no y, we write the y, okay? So we expand this. So what we get here? 21 x power of, what will the power become? Power of 5, minus 12 x squared minus 7x cubed plus 4. Okay, so from here, what is our dy dx? So now you can take the power and times. So 5 times 21. 105x power of 4 minus 24x minus 21x squared. So that's all. There's nothing else to solve. Okay, similar with B, alright? Okay, teacher's going to go to the next one. Composite, okay. When you have composite, this is where teacher wanted to show you the difference. See, just now the question that we did, okay, it was just bracket, equation. So you can expand. But you see this question, here got bracket, but got power. Be very careful. When got bracket and power must automatically use chain rule. Okay, so this is your y, -3. Okay, I'm going to show the shortcut of chain rule. Teacher is not going to do the long one, okay, the normal formula one. Shortcut is very easy. Take the power times with the number in front. Okay, so your dy dx now will become -12. Okay, copy the entire bracket. Make the power 4 less by 1. Then differentiate whatever inside the bracket. Take the front number times the back number. Copy back everything. So you already got your dy dx. That's all. Okay, it's quite easy if you use the shortcut. Okay, for B, similar also. Change the form first. Because you see that the 3x plus 5 with power 2 is below. So bring it up first. 3x plus 5. Power will become negative. Okay, now you do the shortcut. Take the power times the in front one. Becomes -4. Copy whatever inside the bracket. Power must -1. So -2 minus 1, -3. Differentiate whatever inside the bracket. Take the front number times the back number. 3x plus 5, -3. Final answer, don't leave the power negative. Bring the entire thing, go down again. Okay. Alright. So this is quite easy. Okay, simple, can be done. So when they ask you questions like evaluate this, so once you already find your differentiation, substitute the value in. Okay, substitute the value in. Okay, I think I'm now going to go to product rule. Okay, product rule, remember, you need to have two different equations side by side. Okay, it must be equation, meaning that like just now chain rule, if I have number only in front, it's okay, I can use chain rule. But if in front here got x means this is where you must use product, because this will become the u, the behind one will become the v. So you cannot use chain rule here. Okay, if in front got number only, yes, you can use chain rule. Okay, so we will try one question here. Okay, let's try a little bit. Okay, I think they only have to. Okay, we try this one, 32. Okay, differentiate this. Okay, this is our y, 3x squared, 2x minus 5 power of 4. Okay, now this is the u, this is the v. Okay, so I write my u first, 3x squared. Then I write my v, 2x minus 5 power of 4. Okay, find your du dx, which is 6x. Find your dv dx. This one, what you must use for the dv dx? What does it look like? It has bracket and power. So you can't expand this, right? This is 4 times you have to expand. So we use chain rule. So bring the power, go in front, 4. Copy everything. Power reduced by 1. Differentiate whatever inside the bracket. Take the front times the back. So here teacher is going fast because this one all by now you all sitting for exam ready. So I assume all this you all know already. So dy dx, take the u times with the dv dx. Okay, so I'm just going to write in bracket like this. Okay, plus take the v times the dv dx. All right. Okay, now can you see any similarities here? Yes, there is. What are the similarities? 2x minus 5, 2x minus 5. Okay, so now what teacher is going to do first step is, okay, I'm going to factorize. Okay, let me continue down here. Okay, I'm going to continue down here. Okay, dy dx. I'm going to factorize 2x minus 5. Okay, but before that, can you see any other things that can be factorized or not? Yes. Try to see this. 3x, 6x. Both of them have common factors, right? Okay. So this is what we are going to do now. I'm going to factorize 3x. Okay, I'm going to take out 3x. Then I'm also going to take out 2x minus 5. Take with the smallest power, power 3. Take out the smallest power first. Okay. So now what is left inside here? Inside here is left with 8x. Okay, all right. Okay, wait. Before that, before we factorize, going back, before we factorize, yes, this one can factorize. Let's times this one and this first, So 3 times 8 is 24, 24x squared, 2x minus 5 power of 3, 6x right in front, So 2x minus 5 power of 4. Okay, now we factorize. Okay, going back up, I'm going to factorize this and this. Okay, and I'm also going to factorize this and this. So there's two things here we factorize. Okay, let's start with 24 and the 6. Which number is smaller? Take the smaller one. So 6. Which x is smaller power? Power 1. So 6x. Then take out the 2x minus 5. Which power is smaller? Power 3. So I write 3. Now you put the big bracket. Okay, what is the left balance here? How to make it 24? 6 times what is 24? 6 times 4. Then x got another x, so put another x. Okay, then 2x minus 5, no need to write back, no need, because already got outside. Okay, plus. Then here got 6x already, so 6x already got outside, no need to write. You are left with 2x minus 5 power 1. Because 3 plus 1, you get 4. Okay, that's all. Now solve just the last bracket only. Solve the last bracket only. 4x plus 2x minus 5. So we get final answer 6x minus 5. So don't have to expand or anything. Your final answer, leave it in this form. Leave it in this form. Okay. So I hope so far you guys can understand. Alright. So this is interesting. Product rule. Okay, quotient rule. Use quotient rule when you have divide. Remember, when you have divide, it's very important. So like for example, some students don't use quotient rule. You can also still use product rule, no problem. Okay, you can still also use product rule. Okay, let's go through. I think I'll show you the first question 35. Okay, question 35, we can go through. Okay, the others all actually, these questions all are all quite easy. All right, question 35. Find the value of first derivative of h. Okay, so the up one will become the u, the below one will become the v. So u is 7x squared plus 8. V is 1 minus 6x. Find our du dx. 14x. Find our dv dx. Negative 6. Okay, now apply the rule. You don't remember, please refer to your textbook. This is the formula. Okay, so dy dx is, copy the v first. Okay, copy the v. 1 minus 6x. And then copy the du dx. This one is wrong. Teacher should be product rule. Okay, This is the formula. My one is correct. Okay, the one I'm writing is correct. Then copy the du dx, 14x minus, copy the u and the dv dx. 7x squared plus 8 negative 6. Divide the whole thing by v squared. Please take note, do not expand the denominator. Just leave it only. Okay, don't need to expand the denominator. All right, now that you already found your h, okay, this is actually h, hx, first derivative. You can actually expand this, okay, the up one, not the below one. But since they already asked us to find the value, what teacher is going to do is I am going to straight away substitute 1 inside the x so that I can shorten the working. I don't need to expand anything. Put all my x as 1. Find the value. Okay, so 7, 1 square plus 8, negative 6, 1 minus 6 square. Okay, so let's see what's my answer. 1 minus 6, negative 5 times 14 minus 15 times negative 6 divide by, okay, teacher got 4 over 5. So 4 over 5 is my value. Okay, so be careful when you key in everything one by one. All right, okay, quotient rule done. Okay, let's go to question that's I think second derivative easy. Okay, just differentiate 2 times. Yes, application of derivative, meaning that, like, if for example you want to find tangent and normal. Okay, I think I'm going to stop until here and I'm going to do this application part as part 2. All right, so I'll see you guys in part